All right, so we are going to be looking at, given a table, how to determine if the function is linear or exponential. Okay, so the what, why, and how, we will observe some of the differences between linear and exponential functions. Why? Because we want to notice the key aspects of each type of graph and determine if there is a pattern when filling out a t-chart. So how do we know if we accomplished the what today? Well, you'll be able to recognize the differences between linear and exponential functions by comparing their t-charts. Okay, so the different types of functions we've graphed so far. So one type, and this would have been last year if you took Foundations 1, they were linear. Linear has the word line in it. It's just basically just graphing a line. And then here in Foundations 2, 6-1 is all about exponential. So the generic equation for a linear function, if you remember, is y equals mx plus b. This is what's called slope-intercept form because it gives us the slope and the y-intercept. Okay, we're not really going to touch on that. Okay, and then we have these exponential curves. This is what we've been doing. This is what we've been graphing. Okay, the generic form of this is y equals a times b to the x. Now remember, we just learned that the a value is the initial value, which gives us the y-intercept. Okay, and the b is like sort of like our constant, our ratio. Okay, it's our base. Okay, so think about it. Would you rather have $100 now, like right now, $100, and then I give you $10 every year after that? So there's your $100, and then every year you get $10. Just keeps on adding on top of it. Okay, or I just give you $2 now, and then every year I triple it. So you get $2. Then you get $6, and then that becomes $18. Okay, so like, I mean, how long would it take for this to overcome that? Okay, if you don't know, this right here is linear, and this is exponential. Eventually, the exponential will surpass the linear. Okay, so that right there would be the equation. We're starting with the y-intercept, $100, and then $10 every single year. As opposed to this, the exponential, right? The initial value is $2. We're getting $2, and then we're going to triple it every year beyond that. Okay. So again, this is not in your notes. So these are my two functions. So I'm going to plug these numbers in. I'm going to plug them into the t-chart. So if I plug in 0, I get 100. I plug in 1. That's 10 times 1 is 10 plus 100 is 110. 10 times 2 is 20 plus 100 is 120. If you see the pattern of what's happening here, what are we doing? 100 to 110 to 120. I'm assuming the next is going to be 130, yeah. And then 140. So what's happening is we're adding 10 every time. Now with the exponential, if I plug in 0, 3 to the 0 is 1. 1 times 2 is 2. Plug in 1. 3 to the 1 is 3. 3 times 2 is 6. Plug in 2. 3 squared is 9. 9 times 2 is 18. Plug in 3. 3 cubed is 27. 27 times 2 is 54. And then look at this. 3 to the 4th power is 81. And then 81 times 2 is 162. So after 4 years, we will surpass the linear functions. Okay? So if you look here, this is the linear. This is the exponential. And right here, right around here, which is this is 3.5, this is 4, little bit just before 4, this exponential function will be higher than the linear function. Okay, So if we kind of show the points, here they are. Okay, so again, how do we get from one number to the other? Well, we added 10. We added 10. That's what's called the common difference between the y values. Every time it's linear, you add to get from one to the other. So that is a constant rate or difference of 10. That's a linear function. Make sure you put that in there. Okay, so for linear functions, you add or subtract. Okay, and then here, when we look at exponentials, we're multiplying by a common number. It could be multiply or divide. Okay, this is what's called the common ratio between the y values. Okay, this one has a ratio of 3. And what you could do is you can open up a Desmos, take this value, divide by this value, you'll get 3. Take this value, divide by this value, you will get 3. Take this value, divide by this one, you get 3. Take this one, divide by that one, you get 3. That's how you can always get this number. And then from here, you could subtract 140 minus 130, 130 minus 120. You're going to get 10. Okay, so you might need Desmos for it to determine what this ratio is. Okay, so with exponential, you multiply or divide to get from one number to the next. And for linear, you add or subtract to get from one number to the next. And you always look at the y values here. Okay, so let's take a look at that. Okay, so this one's a pencils down, but let's pay attention to it. So let's say we're looking at this table and we want to know, hey, is it linear or is it exponential? Well, I want to see if I'm going from one number to the next, am I multiplying by something or am I adding something to get from one number to the next? Now, what you could do is you can try open up Desmos and do 29 minus 22 and then 22 minus 15 to see if you get the same number. Or you can take 29 and divide by 22 and then 22 and divide by 15 to see if you get the same number. And what you'll see is if you try it, when you subtract, you'll get the same number. But you can even look here and say, oh, 1 plus 7 is 8, 8 plus 7 is 15. I know what I'm doing. I'm adding 7 to get from one to the next. So if you remember, that is going to be a linear function. Okay, and then here, let's take a look. So let's see, it kind of looks like adding. So if these were all positive, it would be 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, but they're negatives. Oh, I know. I can say they're either adding -2, or we could say that we are subtracting 2. Which means that is also a linear function. Try it. Take -10 and subtract -8. And then take -8 and subtract -6. And you'll see you'll get -2 in Desmos. Okay, now here, let's see here. 2 plus 2 is 4. Oh, but plus 2 would give me 6. But that's 8. What about 2 times? 2 times 2 is 4. Times 2 is 8. There we go. Yeah, I'm going to say I'm multiplying by 2. Multiplying by 2. And if you took like Desmos and took any consecutive numbers, doesn't matter where you start. You can take 8 and divide by 4, and then take 4 and divide by 2. You'll see you'll get this common ratio of 2. Okay, but just try it. Do 32 divided by 16, and then on the next entry, you do 16 divided by 8 to show that you do get 2 both times. And because we're multiplying to get from one number to the next, we have a common ratio. We know it's an exponential function. Okay, now y-intercept. Here's how you find the y-intercept. You find the y-intercept by looking for the 0 in x, and I know that this coordinate right there, the 0,8, is my y-intercept. So that also means, if you remember, a is directly related to that y-intercept. So my a value will also be 8. So if I was to create this equation, I already know the a value. Okay, And now here, if I wanted to find what's going on here, I can take, I'm not going to do the fraction one. Maybe I'll take 5 and divide by 10 in Desmos and do 10 divided by 20. Okay? But what's happening is we're really dividing by 2. We're cutting everything in half. But dividing by 2 is the same thing as multiplying by a half. And that's what I need to look at, is I'm multiplying by a half. Because really I want to know what I'm multiplying by. Okay, so again, that's an exponential function. What's the y-intercept? Well, let's look for the 0. There's my 0. So my y-intercept is 0, 20. And then, of course, my a value has that direct relationship with the y-intercept. So my a value will be 20. Okay, so what I want you guys to do is try this next slide on your own. So pause it and answer these questions. Use Desmos. They're already exponential. They're all exponential. So just take this, divide by this divide by that, and that tells you what you're multiplying by. Take this, divide by this, take this, divide by that. You'll get the same number both times. That's what you're multiplying by. Okay? So go ahead and pause it and answer these. So here I'm multiplying by 2. What's the y-intercept? It's right there. 0, 4. What's the a value? Oh, that's 4. What am I multiplying by? This one's a harder one because this one's actually a fraction. It's 1/2. What's the y-intercept? Oh, that's 0, 1. What's the a value? Well, that's connected to the y-intercept, so that's 1. What am I multiplying by? Well, it looks like I'm multiplying by 3. What's my y-intercept? My y-intercept is 0, 2. And what's the a value? The a value is right there. It's that 2. Okay? So let's say we're graphing these. Okay, we have, I already know because of the way this is written, I know it's exponential. It's a times b to the x. So if I was to fill in the t-chart, plugging in 0, I get 1, times 2 is 2. Plug in 1, I get 2, 2 times 2 is 4. Plug in 2, I get 4, 4 times 2 is 8. Now this one's harder because it's -1. So 2 to the -1, remember this brings it down, so that's really a half. And then 2 times a half of 2 is 1. So there's my 1. And then if I plugged in -2, remember that brings it down, which would be 2 times a 4th. And then this actually gives me 2 over 4, which is really just 1/2. Okay, so if I'm graphing, and what am I multiplying by? I'm multiplying by 2. If I'm graphing, I've got -2.5, I got -1, 1, I got 0, 2, I got 1, 4, and I've got 2, 8. There it is, there's my curve. Linear, let's plug in 0. 0 times 2 is 0, 0 plus 2 is 2. 2 times 1 is 2, 2 plus 2 is 4. Plug in 2. 2 times 2 is 4, 4 plus 2 is 6. Plug in -1. 2 times -1 is -2, -2 plus 2 is 0. Plug in -2. 2 times -2 is -4. -4 plus 2 is -2. So -2, -2. I'm adding 2 to get from each number to the next. So here's -2, -2. Here's -1, 0. Here's 0, 2. Here's 1, 4. Here's 2, 6. There's my linear function. I graphed a line. There's a curve. Okay? You can always use Desmos to figure these numbers out as well, right? Remember, we can create that table that I showed you guys how to do. Okay, so this will be what you do for homework. And don't forget at the bottom here, make sure that you type in some sort of summary. Okay, and all right, thank you.